Hello, this is Python Statistical. In today's video, we're going to look at plotting the original, the seasonally adjusted, and the trend adjusted time series for labour force Australia, total employment for persons. So I've written a function called ts_plot, which will plot our time series on a graph. And so to plot the original seasonally adjusted and trend series on the same graph, we just set up a Python list with those variables that we want to plot, as you can see here. And then I pull out the actual labels list from the column descriptions of the spreadsheet in this labels list that I create. So that will tell us what the variables actually are. I will print those labels so we can see. And then when I run this function, we'll actually see those labels on the graph. So the actual data is stored in our Python dictionary at 0 index, and the labels is stored in index 1. So we pull out the data for that catalogue number, which is Labour Force Australia, and then we feed in the variables list here, and then we feed in the labels list for those variables in this parameter here. And I give it the appropriate titles: Labour Force Australia, seasonally, trend, adjusted and original. And we're going to have tick marks every 6 months, which is what that means. So let's run it. And there you go, it's done it. As we can see, we have the original, which looks quite volatile, but that's got the seasonal pattern in there. That's the reason for that. And we have the seasonally adjusted, which is in orange. And then we have the trend adjusted, which is in blue. We can see that the seasonally adjusted series is a little bit more volatile than the trend adjusted series. So cases where it has gone negative, below the actual trend level, could be really due to noise, as there is sampling error in this survey to account for as well. I've also recorded how long it took. So it took only 63 seconds to run this code. So it actually went through all the spreadsheets that are in this publication and produced a graph in that time. To do that, to measure that time, I use timer. That's available in a time.it library. So I start the timer at line 19. And then I stop it at line 191 and then print the runtime in seconds. Another feature to take notice is that the seasonal, which sort of starts in August to about February, what we need to notice about that is that as the level increases, the magnitude of the seasonal is increasing. This tells us that the appropriate decomposition for this time series is to use the multiplicative decomposition rather than the additive. The additive would assume that the seasonal is constant. As the level changes, it would remain constant, but in this case it does not. So a multiplicative time series model takes the form of the original at time t equal to the trend component at time t times the seasonal component at time t times the irregular component at time t. So this is different from an additive model where you would have trend component plus the seasonal component plus the irregular component. So if we were to divide by the estimated trend, we would get a detrended time series. And in this detrended time series, we would see the seasonal pattern and the irregular. So that brings us to the end of this video. If you liked it, give it a thumbs up. If you disliked it, give it a thumbs down. And if you really like it, please subscribe to Python Statistical. Thank you for watching.